Okay. I'm testing this out. Just testing this out. Okay. So, yeah, so basically, what I'm going to be doing is getting into, Unit 1. So before it was Unit 0, they kind of just went into very introductory stuff, kind of like the basics of programming, and now I'm going to kind of get into, um, things like Java. But I kind of want to test OBS streaming on NVCAP Code. I'm doing this from a service plaza, so I'm testing it out. Yeah. So it looks good. Looks like it works. I think what I'm gonna do. Is start from. Because right now it just says test. Maybe I'll just change the name because it clearly works. But okay, hold on. It's not letting me click anything. Okay, settings. Oh, manage broadcast. I think that's what it is. Oh, let's create out. It's weird. Yes, I'm just trying to change the name of the stream. Ah. I can't change the name of the stream. Alright, yeah, that's alright. Okay, I'm trying to change the name of the stream. Okay, stream. Yeah. So, I guess for now, it's stuck at like that. So I'm gonna just end the recording, but I'm not gonna end the stream. What I'm gonna do is I'm gonna make these tutorials can happen in real time, where it's gonna be, a live. It's gonna be live, but I'm gonna chop it up into recordings. So, basically, the first kind of couple of tutorials, and actually I'll just look at them right here. In Unit 0, hold on. Nah, I don't do that. Okay, so I'm just moving things around. Okay, so yeah, I think I'm ready to start recording. What I'm kind of about to talk about is, you know, what was taught in Unit 1, you know, and how we're going to build on that into Unit 0, rather, into Unit 1. So yeah, I'm actually going to hit record. I think we're ready. Alrighty, TV. So basically, this is going to be just people coming in. This is going to be real-time tutorials for the coding channel. This is going to be in kind of real time. I'm going to kind of have it like up like a stream, like a live stream, and I'm going to kind of record in OBS like the individual tutorials itself, but they're going to be put up like in real time. So that's going to happen. So I'm actually going to get started on the first tutorial and recap what we learned in Unit 0 and how we're going to bring that into Unit 1. So I'm going to hit record. Okay, so this is NVCAP Code. Let's do a recap on Unit 0. So this is Unit 1. So basically, in Unit 1, we kind of talked about, what a computer was. It basically has an input, it computes something, and then has an output. That's pretty much what a computer is. And, we saw kind of how code works in general. Where we would have, like a calculator is a computer, where you would have maybe, let's say you have two numbers, right? And you would have an operator that the computer would manipulate all those things to turn it into an answer. So it's kind of like if you just have a calculator without any kind of programs, it wouldn't do anything. It wouldn't be like 5 plus 5 will equal anything. What has to happen is you would have to throw one of the numbers into a variable, right? It would have to remember, like let's say you're trying to add two numbers. It would have to remember the first number. It would have to remember the second number, and it would have to remember what you're trying to do with the numbers. That's what it would have to do. So in this case, we have the input for num1, 14, and for op plus, and for num2, 15. So then what the computer did was it would arrange that to produce 29. And we talked about kind of how it would do that. So basically how it would do that would be, it would kind of initialize num1, op, and num2 as, as nothing, basically. It would have to be initialized. It would basically have to be set to like 0 or something. Because if it's not initialized, if a variable's not initialized, what would happen is when it first refers to it, it'll throw something called a null pointer exception, which means that basically the computer is being asked to point to nothing when there's nothing there. So that's kind of but in general, how you kind of would plan this out would be if op is plus, it's going to add the two numbers, and that's going to be set to answer. If op is minus, it's going to subtract one of the numbers from each other, and its answer is going to be set to num1 minus num2. So you have to tell it exactly what to do. So and then kind of what a variable is in general is, what is a variable? So if you think about it this way, let's say I give you an instruction to, you know, I don't know, we could think of anything, you know, like let's say I'm telling a human to add two numbers, right? Well, like you would basically tell the human, right, the two numbers you want to add, and then the human would just know, if it's good at math, to spit out the answer. But what does it have to do? It has to remember, right, what those, it has to remember what it's told. So if you give someone an instruction, they have to remember what they're told. They have to remember that you're telling them to add numbers. You're telling them to that num1, let's say it's 7, and num2, let's say it's 9, and to add 7 and 9. It has to remember all those things to add both of them up. Otherwise, even if it can add the numbers, it's not going to add the numbers because it doesn't remember what numbers to add. And every single instruction has to be explicitly stated. A computer doesn't just know anything. So basically, a variable, as defined, is a piece of data that is stored into memory. So basically, it's like, imagine you remembering a number. It would take a piece of memory in your brain to remember it. It's the same thing with a computer. It would be a very small allocation of memory that would be associated to that number being remembered, or that operator to be remembered, whether it's plus, minus, whatever, right? So basically, a variable is just, a way of just remembering what it's doing. And also, if this is just totally new, you would really need to check Unit 0. This is just kind of a review. But I'm just the main kind of point of this video is just to show how Unit 0 will build into Unit 1, and just recapping Unit 0. So piece of data that is stored into memory. So that's pretty much what this is. Like let's say num1 equals 3. Basically, it's actually how it would actually work is the memory ID would be 1, and the memory ID would be 2. So there's kind of something called memory addresses, but I'm not really going to get into that. I think I talked about that just like to explain kind of how it does it. Yeah, so and this is a good point. So this is something called data types. Is when you're adding a number, right? When you have the variables that are set to, let's say these things, right, that are basically boxes of information to store in their memory, right? They have to be a certain type. Like, are you remembering a word? Are you remembering a number? What exactly are you remembering? So if you're just remembering, let's say a basic number like 5, 6, 3, that's going to be called an integer. If it's, let's say it's 5.465, that's going to be called a, well, it can be, there's many things you could call it in other languages, but that's going to be, that could be a float, that could be a double, but it's basically something to express, it's actually something called a data type to, describe what kind of information is being stored in that variable. And every time you initialize a variable, you would actually declare that data type. So if you want to remember, an integer, right? you know, it would be a variable num1 is an integer, and set that to 0 for now, basically, you know. Or let's say you're trying to get them to remember like a decimal, like 5.65. So this, you would be maybe a variable num2 is a double and is equal to 5.65. And let's say, you know, you're trying to get the variable to remember, you know, like a name, like NVCAP or something, right? You know, that would be, in order to remember any kind of text information, that's going to be something called a string. So, you know, it would be called like, you know, variable name is a string, and set that equal to, in quotes, NVCAP. And that's how it would work kind of in a programming language. And I'm just showing this to just kind of explain conceptually what it is. It doesn't have to make a lot of sense right now. And, you know, if you're, let's say you're trying to just remember one letter, right? If you're trying to just remember one letter, that would be something called a character in Java. So a character would be, you know, basically like just one letter. And kind of the point of that would be is, you know, let's say, you know, we have op right here, right? And we want op when it's plus to tell the program to add those two numbers. Or when op is minus, you want to subtract two numbers. So there, a string wouldn't make any sense, right? So that would, you would actually set op as a character variable and set that equal to a plus when you're trying to add it, and a minus when you're trying to subtract. And then kind of another important disclaimer is, let's say you're trying to add 5.63, right, as a double, to, you know, let's say integer that's 3. You know, you would think, oh, in our heads, that would just be like 8 point whatever the last decimal places were, right? But the problem is, that would not work. That program would crash. And it would crash because you actually have to have them be the same data type in order to add them, basically. So it doesn't really work the way you would think it works. So, and if statements in general, you know, if statements in general is basically if, you know, this condition is true, right, then do this. So let's say you're making a program to tell a human that they better put on an umbrella if it's raining. So you would probably want maybe a variable called is it raining, right? And if is raining is true, have an umbrella. If raining is false, don't have an umbrella. That's simple, you know? So basically, in general, how statements work is if this statement is true, then, you know, execute this code. Something and a null value. In general, that's going to be an integer. In general, yeah, I think I was just continuing on there. Yeah, but then I got kind of the second part of the unit, which was kind of the basis of computing. So I already kind of explained the basics of a computer, you know. But what about computing? So I think that you probably might know that how computers kind of work is they basically deal in the ones and zeros. So basically everything and anything that you're using from like a web browser or whatever it is, it the basis of all of that is ones and zeros. It's kind of like almost like to a cell for humans. It's like the fundamentals is ones and zeros. And how you're arranging those ones and zeros turns into all these complicated, nice things. I can explain. It's a long thing about how it does that, but basically, what a bit is a term called a bit. It's either a 1 or a 0. That's what a bit is. So, and what a byte is so just a bit alone, that can't really represent anything. So what a byte is it's actually 8 bits. And basically how that works is, you know, like I actually can, like basically if you were to represent the let's say 0, right? It would be 8 zeros. And then if it was going to be like another number, it would be a different arrangement of those 8 bits. And that would be how that would be how that would be arranged. So it's kind of like, I just want to kind of get later. I think I was describing it. So I'm just like backtracing here. Where okay. So basically there's, let's just say in general, let's say we're not talking about binary code at all. Say we're talking about regular numbers. That's called the decimal system. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the decimal system. And if it's a binary system, it's just 1 and 0. So the decimal system, there's 10 possibilities of what it could be, but in the binary system, there's only 2 possibilities of what it can be. So what that's called is the decimal system is called the base 10 system, because there's 10 possibilities of what it could be. It could be a 0, it could be a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, or a 9. That's 10 possibilities. If it's only 2 possibilities, it's a 0 or a 1. If it's only, let's say it's a base 4 system, it would be, how that would look is you would start at 0, 0, 1, 2, 3. So, I'm kind of explaining how it would go from how you actually count and translate from a binary system to a decimal system. Yeah, and by the way, I would say that anyone who just hasn't seen the actual Unit 0, this is just like a review. It would make all the sense in the world to be a little lost, because if you just didn't watch the like I think anyone who just didn't watch the prior information, there would just be no way for this to just make perfect sense. And but yeah, so I'm going to kind of show like what it would look like, kind of going from the binary system to the decimal system. So how any system even need that binary. Trying to remember what I was doing there is for this situation, right? How binary would work. Okay. Right? So let's say, in the decimal system, right? You're trying to represent the number 3,461, right? you would have a thousands place, you would have a hundreds place, a tens place, and a ones place, right? And then you would put the 3 in the thousands place, a 4 in the hundreds place, a 6 in the tens place, and a 1 in the ones place. And we were taught that in school. And then another way to represent that would be 3 times 10 to the 0, right? Oh, actually, I made a mistake here. That was actually supposed to be a 1. Yeah, that was supposed to be a 1. My bad. I actually have to plug this in. My computer's dying. Yeah, just 1 sec. That's actually over here. Hold on. So because I actually made a mistake on that one, I'm actually gonna do one from scratch. So let's say, you're trying to represent the number 3,500 and, I don't know, 56. And I'm actually writing on on my most pad here, right? Let's say you're trying to represent this. We learned in school that, there's like a thousands place, right? And there's an important reason why I'm explaining this. There would be a thousands place. There would be a hundreds place. I'm trying to just draw this out. There would be a tens place. And there would be a ones place. Hold up. Let's just get this table made. So how would you represent that? You would say, okay, 3 is in the thousands place, right? 5, that's in the hundreds place, right? This 5 is in the tens place. And this 6 is in the ones place. So that's how you would represent, that's kind of like our understanding of the decimal system, right? I just want to draw a better 3 than that. That's a terrible 3. Yeah. I'll try to, I don't know, hold on. I'll try to just fill this in. I'm trying to just redo my 3. It's a very bad 3. It's not letting me really redo my 3. Oh man, it made it worse. Hold on. Oh, I just need a moment. Hold on. I just need a moment. I'm just gonna put it in. I'm just gonna put it in text here. Hold on. Okay. I know. Hold that for a 3. So let's think about what's going on here. We have thousands, hundreds, tens, and ones. How else can that be represented? Isn't 1,000s? Isn't 1,000 also 10? Well, actually, so okay, isn't 1,000 also 10 to the 3? So 10 times 10 times 10 is 1,000. 10 times 10 is 100. So 10 squared, right? 10 squared is 100. 10 to the 1 I'm not going to redo 3's anymore. 10 to the 1, just 10 of itself, is 10. And what is a 1? So we don't really, it's hard to think about, you know, 1 being represented as an exponent from a 10, right? Because it's less than 10. But if we follow the order, 3, 10, if 10 to the 3rd is 1,000, and 10 squared is 100, and 10 to the 1 is 10, just count it down. 3, 2, 1, it's 0. I'm going to try to draw that 0 as best as I can. So 10 to the 0 is 1. So why the hell am I bringing this up? And what does this have to do with programming? Is how you would convert a number in the binary system is the same way. So instead of a thousands place, think about it, instead of a thousands place, think about it as a 10 to the 3rds place. Instead of a hundreds place, think about it as a 10 squareds place. Instead of a tens place, think of it as a 10 to the ones place. Instead of a ones place, think of it as a 10 to the zeros place. So if you were to represent another number, let's actually have a 2 to the 3rds place. You know, let's have a 2 squareds place. Let's have a 2 to the ones place. I'm actually trying to draw a line here. And a 2 to the zeros place. So let's try to represent numbers. Oh, whoa, hold on. Let's try to represent numbers in the binary system. So let's say, you know, we're going to represent the same kind of number. 3, 5, 5, 6. What happens here? what happens here, you know, is just like, think about this, right, as how you would kind of figure out what this would be. Let's say you didn't see the number, right? That number would be 3 times 1,000, right? Plus 5 times 100, plus 5 times 10, plus 6 times 10 to the 0, which is just 1. So anything to the 0, by the way, is just 1. So this would be 3 times 10 to the 3rd. So this would be 3 times 10 to the 3rd plus 5 times 10 squared plus 5 times 10 to the 1 plus 6 times 10 to the 0. And there's a reason why I'm representing things this way. So if we were to take this number, right, in a binary system, instead of 3 times 10 to the 3rd, it would be 3 times 2 to the 3rd. So it's almost like there's a 2 to the 3rds place. And then here it would be 5 times 2 squared. And then it would be 5 times 2 to the 1. And then 6 times 2 to the 0. So right, and then if you were to just add it up, you know, that's you know, that would turn into you know, some kind of answer, right? But here's actually the problem, is these numbers, right, are a base 10 system. So it doesn't work. So you can't actually do it. So what you would instead do is you would have, let's just I'm just gonna put a box here. Alright, hold on. I'm trying to... I'm trying to, sorry letting me though. Yeah, so I'm just actually gonna, just gonna try to, hold on. Just like use more space, hold on. Okay, I'll just zoom in another area, like here. So, if you want to actually represent a number in the binary system, and let's say you had a 2 to the thirds place, or a 2 squareds place, or a 2 to the ones place, or a 2 to the zeros place, what is the basis of the binary system? It's 0 and 1. This is what the binary system is made of, is based of. Actually, I just won't. I'll say binary. And if it was the decimal system, it would be based of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that would be the decimal system. So we'll see how this would look. So let's say, okay, I'm gonna make this a 1. So since it can only be a 1 or a 0, maybe I'll make this a 1, and maybe I'll make this a 0, and maybe I'll make this a 1. Now this is a correct way to represent a binary number in the binary system. So what this would be 2 to the third, just like the base 10 system. How this was 3 times, that would include a basis of the binaries of the decimal system, because 3 is within 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the third, plus a 5, which is within the base 10 system, times 10 squared, plus 5, which is in the base 10 system, times 10 to the 1, plus 6, times 10 to the 0 in the base 10 system. So just like that, we have a 1, which is in the binary system, a 1 which is within the binary system, a 0 which is within the binary system, and a 1 which is within the binary system. So it checks out. Let's see if we can do it. So 1 times 2 to the third. What is 2 to the third? What is 2 times 2 times 2? It's 8. So that would be 8. One times 2 to the 0. What is that? It's 4. What's 0 times 2 to the 1? What is 2 to the 1? It's 2. Like if it's to a power 1, it's itself. But if it's but what's anything times 0? It's 0. So this is 0. And the last number, what is 2 to the 0 again? Right? It's just 1. So 1 times 1 is 1. So then this would be 13. So how you would represent 13 in the binary system would be 1, 1, 0, 1. So if you can just learn kind of how number systems work, you can write all kind of binary numbers. You could have made so like how a regular byte will be is it'll always have kind of by default 8 places. So why is it 8 places? Because basically that well, actually that's a rather complicated thing. I'm not really going to get into that, but you know you can take any kind of binary number. So let's say you wanted to let's just do more of these. Let's say like let's start with 2 to the hold on. Let's actually use up to 8. 0, 1, okay, 1, 2, 3, 4. 4. Okay, hold on. We're gonna use a challenge here. I'm just gonna kind of just, it's just gonna be repetition, just so it's understood. So you have a bunch of 2's. I want to make it so we have 8 2's. I want to get you used to having 8 places. It looks and sounds like a duck. It's a duck. 1, 2, 3, 4, 5, 6. I'm just reading the comments. 7. Yeah, 4. Okay. Okay. So get a 2 to the 0's place, a 2 to the 1's place, a 2 squares place. Oh, sorry, my 2's look like ducks. Sorry about that. A 2 to the 3rd place, a 2 to the 4th place, a 2 to the 5th place, a 2 to the 6th place, a 2 to the 7th place. And now, just so we have it, to reference, what is 2 to the 0? It's 1. It's 1. What is 2 to the 1? It's 2. What is 2 squared? It's 4. What is 2 to the 3rd? It's 8. What is 2 to the 4th? That times 2, 16. What is 2 to the 5th? It's 32. Times 2 again. What is 2 to the 6? Times 64. Times 2 again. 2 to the 7. 128. So we're going to have another representation of numbers. Let's see what they be. So what I'm about to write down are binary numbers that we're going to translate into, sorry, I'm going to sneeze. No, I'm not. Sorry. So what I'm basically going to write down are a bunch of binary numbers we're going to actually convert into decimal. So let's start with an easy one. 0, 0, 0, 1, 0, 1, 0. So we're taking the binary number 0, 0, 0, 1, 0, 1, 0, and we're trying to figure out what that would be in decimal. So, oh, and there needs to be a 0 here. Sorry. So, what is that? Well, just like how, again, just great going back, just how we would do this in the decimal system, right? We would have a basis of the decimal system, 3, times the thousands place, which is 10 to the third. 3 times 10 to the third, plus 5, which, in the decimal system, times 10 squared, plus 5 in the decimal system, times 10 to the 1, plus 6 times 10 to the 0. Same thing. So this is just going to be 0 times 0 times 2 to the 7. What is 0 times 2 to the 7? What is 0 times anything? That's going to be 0. What is 0 times 2 to the 6? Also 0. So we're trying to figure out what this number is. 0 times 2 to the 5th. It's going to be another 0. Okay, a 1 times 2 to the 4th. So 1 right? Plus 0 times 2 to the 3rd. Zero times 2 to the 3rd. Plus 1 times 2 squared. So I'm just adding this up. 1 times 2 squared. Plus 0 times 2 to the 1. I'm just going down the list. Oh, That's going to be 0 times 2 to the 1. And then it has, I guess, another 0. Zero times 2 to the 0. Alright, so let's just add it up. 0 plus 0 plus 0, right? Let's just try to simplify it. So all this would just be, 0. Zero plus 0 plus 0 is 0. 1 times 2 to the 4th. What's 2 to the 4th? It's 16. So 16. Zero times 2 to the 3rd. It's just 0. We don't have to worry about even think about the 2 to the 3rd because it's just 0. Plus 1 times 2 squared. 1. Oh no, sorry. So 1 times 2 to the squared. What's 2 to the squared? 4. So that's plus 4. Plus 0 times 2 to the 1, it's just 0. I don't even need to think about the 2 to the 1, even though it's just 2. So that's just 0. And then 0 times 2 to the 0 is just 0. And then we have kind of a relatively simple problem. 0 plus 16 plus 0 plus 4 plus 0 plus 0. The only real numbers we're really adding up is 16 and 4. So that's 20. So now you know that 0, 0, 0, 1, 0, 1, 0, 0 is 20. So let's say you wanted to go the other way. Let's say you wanted to start converting, binary numbers to the decimal system. We'll see that. Aliens stopped him before he could open up the portal. Oh man. That's not good. So let's count in binary. Let's count in binary. So let's say I'm going to try to represent the number 0. And I'm going to use, I'm going to represent this in terms of bytes. So it's going to have 8 places, right? 0. I'm just going to write 8 zeros for no reason, and that's just going to be 0. 8 zeros for no 8 zeros. That's 0. It's a bad 0. 0. What the hell was that? So let's say, I want to represent a 1. That's going to be 0, 0, 0, 0, 0, 0, 0, 1. Now, why is that? Because, oh shit, just like back to the original thing, the 2 to the 0th place is 1. So it's 1. So let's actually put back the places, you know, to go back to the earlier example. What we're going to be doing is counting in binary. Whoops. Five, 2 to the 6th, 2 to the 7th. So what's 2? What's 2 in binary? Well, so how you want to think about it is it's almost like division going backwards. So 2 to the 7, you know, referring back to it, that's 128, right? You know, so you're not going to need to use a whole 128 to represent 2. So that's going to be a 0. So 128 does not go into 2, right? So 2 to the 6th, that's 64. Does 64 go into 2? No. 2 to the 5th, that would be 32. Does 32 go into 2? No. So it's almost like it's like a switch. You shut that off. You don't need it. 2 to the 4th. What is 2 to the 4th? That's 16. Does 16 go into 2? No. 2 to the 3rd. Does 8 go into 2? No. Does 2 to the squared go into 2? Or 4? Does 4 go into 2? No. Does 2 go into 2? Yes. And now, once you've used that up, basically, the 2 to the 1, you know, it's kind of like division, where you have nothing left. You've used up 2. So 2 minus 2 is 0. So now you have 0 left, so it kind of cuts out even. So if there was anything left, you know, you would use it, but it would be a 0 because there's nothing left. So that's how to represent 2. That number's 2. Let's try 3. Let's try 3. Does 128 go into 3? Probably not. Does 64 go into 3? Probably not. Does 2 to the 5th? You only really need to know. Probably not. Probably not. 2 to the 3, that's 8. Probably not. 2 to the 4, it's starting to get close. Does 4 go into 3? Still, no. We're getting close though. Okay, does 2 go into 3? It does. So now, you've used up a 2. So now what do you have left? You just have 1 left. And luckily, and I'll explain later how it's not luck, but you only have a 1 left, and the last place is 2 to the 0, which is 1. So now, you've used 1 up. And now it divides in perfectly, and, you know, you got your 3. So this is, that's 3. So 0, 0, 0, 0, 0, 0, 1, 1 is 3. Let's try 4. Let's try 4. You know, we don't really need to think about even these. 2 to the 7, 2 to the 6, 2 to the 5. We don't really need to think about that. 2 to the 4. We don't need to think about that. 2 to the 3rd, that's 8. We're starting to get close. 2 squared, that's 4. So, I'm going to use that up, because 4 does go into 4. But, since I've used up 4, 4's place, it's now 0. So when that happens, there's nothing left. You've already used it up. You just know that these are zeros. You just know. They're 0. Let's try 5. And I'm only going to go up to 9, I think. But I'm just to hit the point home. 5. 0, don't need it. 0, 0, 0, 0, because that's 8, 2 to the 3rd. 2 squared, that's 4. So we're going to use a 4 up. We're going to use a 4's place up. So what happens then, there's a 1 left. So 2 to the 1, that's 2. Does 2 go into whatever's left? Does 2 go into 1? No. 2 doesn't go into 1. Does 1 go into 1? Yes. So now you know that, you know, really these zeros before it are kind of redundant a little bit. You don't need them. Like, the only reason why I'm representing them in 8 is because I wanted you guys to get used to that being represented as a byte. But really, you obviously don't need these zeros before. But now you know that the number 5 is 101. Now you know the number 4 is 100. Now you know the number 3 is 11. Now you know the number 2 is 10. Now you know the number 1 is 01. Now you know the number 0 is just a bunch of zeros. Let's try 6. We're almost there. We're almost at 9. So 0, 0, 0, 0. 2 to the 8 still, that's 8. Doesn't go into 6. 2 squared. So we're going to use a 4's place, 2 squared. Now it's left. 2's left. 6 minus 4, it's 2. Does 2 to the 1, 2, go into 2? It goes into it perfectly. So that's 1. So now you've used up a 2's place, and now it evened out. So now you just know, whenever it gets to a point where, you know, it's kind of zeroed out, you've used a place and now the result is 0, you just know that the rest of them are 0, but there's only 1, so you're just going to know it's 0. So now 6 is a 110. 7. And actually, let's do this even easier, because it's maybe seeming redundant by now. And I kind of wanted it to seem redundant for a little while, just to kind of show like how easy it can get. Well, not easy, but like how just methodical it can get, where you can actually start noticing a pattern. You know, where this 6, right, was, okay, well this 0 was 2 to the 0, this 1 was in the 2 to the 1's place, this 1, right, was 2 to the squared's place. So, so I'll put it this way. It went from 0, 0, 0, 1, 1, 0, 1, 1, right? And then you're in a new one. You're like a new, okay, actually, here's what how I'm gonna think about this. Here's what I'm gonna do. It goes from 0, then 1, then it jumps up to the next place, then 1, 0, then 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0. So 7 is going to be 2 to the 4th. So just think about how this one from 1, 0, and then it's 1, 1. This is going to be 1, 1, 1. You know, and what happened every time it got fully populated by 1s? It goes up to the next place, right? It just goes up to the next place. So, you know that it's going to be 1, 0, 0, 0. And that makes sense because 2 to the 3rd place is 1. 2 to the 3rd place is 8. So to represent 8, 1, 0, 0, 0. To represent 9, it's just going to be that plus 1. So it's going to be 1, 0, 0, 1. Yeah. So yeah, we got a, yeah. So that's pretty much counting in binary. And that's pretty much, yeah. So this is kind of just like practice stuff. Yeah. Sorry. Yeah. So okay. So yeah, that was counting in binary. So now let's go back to what else we covered. Oh, what is it doing? Counting in binary. Yeah, that was pretty much it. That was like kind of the last concept. Oh, whoa, oh my god, what the hell happened? And I'll just cross it out. That's crazy. It'll be 1, 0. Then, so yeah, now, this is just the last concept, and this is not really, involve binary or anything, or math, too much math. And so basically, just when you program, you're not just typing it how to organize programming languages. It's just line by something, but I'm not sure if we're ready for that. But basically, for now, just it's kind of like kind of like a middle ground between the purely
Hold
the
on.
zeros and ones, and then
Just want to make
Java,
sure everything's
Python,
set
and
up.
C are kind of the spoil programs where to humans where basically it's almost like English.
It kind of works
just
like
language we understand. And
the
assembly is
basics of the
kind of in
basics,
between.
right?
It's basically instead of
Is
zeros and ones, it's gonna have like
is going to be
a lot of commands. It's gonna be something that is gonna be more
ones and zeros, right? There's something called
it's gonna be
assembly
more connected
code,
with the machine,
which
of the
is
computer,
kind of very hard to read code. You know, it wouldn't really make any sense if you saw it. What is it doing? It's just
So I've got my essay written, and I've been working on it for about a week.
It just totally
So now I'm
took
going to show
over.
you how I use Grammarly
That's
to edit.
strange.
Okay, so here's my essay, and I'm going to click through.
So,
Yeah, sorry.
this is a very example of an assembly program.
You know, where basically it's kind of like,
could be,
you know, it's measured by like a low-level language to a higher-level language, which is basically like the closer it is to those zeros and ones, the lower level it's going to be as a language. And the higher it's going to be as a language is how more it's understandable to humans, basically. That's the way to think about it.
So basically it would be
if you were to look at Java code,
at system level.
it almost
Actually,
looks like a set of instructions.
I was gonna load something.
I mean, some people could
I'm not
probably
sure
see
if
it. It
we're
would
ready
look
for that. But
complicated.
basically, for now, just take that as kind of
but-
like a middle ground between the purely the zeros and ones, and then Java and Python and C are kind of the spoil programs where to
OBS
humans
is
where
just very
basically
glitchy.
it's almost like English, just language we understand. And assembly is kind of in between. It's basically instead of zeros and ones, it's gonna have like you know, a lot of commands. It's gonna be something that is gonna be more it's gonna be more connected with the machine of the computer. Basically, it's the best way to understand it.
Okay.
So I've got my essay written, and I've been working on it for about a week. So now I'm going to show you how I use Grammarly to edit. Okay, so here's my essay.
That video again. Man, alright. So basically,
Python
if you were
and C are kind of
to
the spoil programs where
if you were
humans
to
where basically it's almost like English,
if
just
you were to
language we understand. And assembly
basically
is kind of in between.
just
Basically
read
instead
binary
of
code, it would be just a bunch of ones and zeros.
It's gonna have like
wouldn't really be
you know,
understandable. If you were
a lot of
to
commands. It's gonna be
read assembly
something
code,
that
it would kind of it would
is
be
gonna
really
be
complicated,
more,
but it would kind of almost look like words, but not really.
It's gonna be more
And then
connected
if
with the machine of the computer. Basically, it's the best way to understand it.
if you like looked at something called Java, it's basically higher level. It's almost like you would think about it as like
So I've got my essay written, and I've been working on it for about a week.
To the machine
So now I'm going to show you
computer.
how I use Grammarly to edit.
And the more kind of
so
you
here's
get
my
closer to the
essay,
machine of the
and I'm going to
computer,
click through Grammarly suggestions
the
in
more
the
it's
right
going to be a
panel.
lower level language, and the higher level language is going to be more.
Your sentence may be
kind of
unclear or hard to
convoluted
follow. Consider rephrasing. That's true.
You know,
This
how
is much
humans.
You know, I didn't know
You know,
my writing contained so many
interact. So,
run-on sentences until I started
That's
using Grammarly.
just a full review.
This paragraph
of
may be
Unit
too long. Consider
0.
starting a new one here. It is too
I'm
long.
going to kind of end off
And that
with
is the perfect spot to break it.
saying where it's going to go. Is there's so basically you know, the next thing we're going to learn is Java. You know, and it's going to be a real programming language. We're going to install that. We're going to get it to work. And, you know, it's going to actually kind of create some kind of program that we can use. You know, so I'm going to kind of end that video. I'm not going to end the live, but I'm going to end the video. And then start recording again. Okay, so basically, in between these lives, I'm now going to start on, I'm going to start on kind of showing how a programming language generally works, you know, kind of how those ones and zeros get turned into, basically Java code, happens through a compiler. So there's usually like a, so a compiler basically, it's kind of like if you were to have that code, right, before, let's say that calculator code. Actually, I'm gonna start making the video now. So, just as a final review of Unit 0, kind of showing how it all ties together is, the first language we're gonna learn is Java. So, basically, if you remember that code where it was basically showing like how kind of code would look if you were coding like a calculator, like the num1, the num0, the num1, the num2, the op, and the if statements to say that if op is plus, you're adding them, if op is minus, you're subtracting num1 and num2, So the language of that was very similar to Java, and there's just kind of a concept to be kind of understood about a compiler and an interpreter. Let's see. A compiler and interpreter. So, some reason I just want to double check my spelling. My spelling's really bad. Yeah. Compiler versus interpreter. So what are those? It's basically, as kind of described before, it was all a game of kind of going from, kind of almost human-based code, almost seemingly human-based instructions, right? Code, right? And at some point translating them to kind of computer ease, which is just a bunch of ones and zeros that the computer can understand. So I'll just type in a bunch of ones and zeros, because that's all computers know. So, there's many ways that I could do this. Let's say that this was, a program. Say this was like a calculator program. I'll call it a calculator program. So what a compiler would do, right? Here's what a compiler would do. Is it would take this entire thing all at once, right? I kind of don't really even need to type anything. It would just take this entire thing all at once and then turn it into those ones and zeros immediately, right? And what an interpreter would do is it would actually do it line by line. So let's say the first line. So actually, hold on. I want to kind of copy this. Yeah, I want to copy this. Control-C, Control-V. What would an interpreter do? Would be where there are lines of code, right? Lines of code, lines of code, lines of code. I'm trying to kind of make them line up a little bit, right? It would translate kind of line by line into those ones and zeros, line by line into those ones and zeros, and line by line into those ones and zeros, and line by line into those ones and zeros. And it's almost like an interpreter, right? Like in the just the general sense, like, you know, like what would an interpreter do? It would read kind of one line of a book, and then someone from that can know another language would read that line, and then you would take in the information line by line, because humans don't take information page by page. You know, that's why they kind of call it an interpreter, because it's line by line. So it doesn't really matter. It'll both get the job done, but you know, there's different some languages are compile based, and some languages are called interpreted languages. So Java would use a compiler, meaning that you would have a Java program, you would hit run, and then the entire thing would just turn into a working program. And the Java compiler has a name. It's called the Javik. Let's just go over a bunch of things. And this is actually a good example. Like, what is an interpreted language? It would actually be Python. Python is an interpreted language. So this is Python. Or this is Python. You know, like, let's look at some Python code. I'll just open the entire image. Is basically how it would work is you would actually see it run by line by line by line. And, you know, we can talk about the value of that if there is any, but it's like some languages have interpreters and some languages have compilers. That's really all you need to know. There's a set of things you basically need to install to use Java. They're going to use is something called the Java JDK, and you know, that'll basically have everything: the compiler, and what's chat saying? Yeah, actually, I'm just gonna read chat on here. I can't really read chat. Hold on. And yeah, so we're gonna get into next is basically how kind of how a like what exactly to install. Like, if I want to use Java right now, what do I need to install? So let's do it. So I've kind of made what I'm going to call Introduction to Java video. So I'm going to stop recording there. So I'm now going to going into the next video. I'm going to show installing Java. What exactly do you need to do to install Java? Now, I don't use a Mac ever. I don't use any Apple products. But it should be somewhat similar. But yeah, I don't know. I just don't use any Macs or any kind of Apple products at all. So it will be kind of a PC-based tutorial. But you know, I'm going to kind of show how you would, you know, install Java. Let's install Java. So I'm now going to make the new video, installing Java. So recording. Okay. So I started recording the video. So, you know, it can kind of be very simple. Just download Java. Download and install Java. I would type in NetBeans bundle with JDK. I would type in that. So, what the JDK is it's the Java development kit. It's basically everything you need to create a Java program. But we'll get into that later. For now, we're just installing Java. I haven't done it in so long, but yeah, it's here. So I'm gonna link this website, and I believe it's, yeah, I do believe this is the one. I just want to make sure. Wait, they changed it. It's different. Wait, hold on. Okay, installing on Microsoft Windows. Yes, I don't think this is a good website. I don't know, maybe this, I guess. Yeah, before they had a bundle, you could just download both of them. Is this it? No. Alright, well, we're just gonna install it one by one. Before you could just install it together, but I guess you can. So you would just kind of go to this website on Windows. This would install. But actually, I think on the NetBeans website, they have to have a bundle. They have to. Because I want it to be confusing. Yeah, I'm actually okay. So in the live, I'll actually stop the recording. I won't go with that video. I'm gonna redo the video, but I'm gonna make it so I can find the bundle because they made it way different from what I remember. They don't have the bundle anymore. Like why would it?
Oh, okay. Is this Apache? Yo, what the hell? Yeah, they changed everything on this. Until I see something that works, I'll download it. So it's downloading. Alright, it's almost done. Open when done. Okay, the installer will install IDE on the following packs and runtime. It will install. Okay. Okay. So I think I found a good link. Alright, so now I can start the video. So so basically I'm gonna have you guys go to this website. The link is gonna be in the description. If there's any issues you guys have, let me know. But basically, we're going to be installing Java. So when I first installed Java, it was way different than it is now, apparently. And, you know, so I kind of actually had to learn how different it was. But basically, you're going to click on this link, and I'm going to have this link in the description. I think I'm just going to have a text editor here. Oh, where'd it go? So I'm just gonna type this in chat.
So I've got my essay written, and I've been working on it for about a week. So now I'm going to show you how I use Grammarly to edit. Okay, so here's my essay, and I'm going to click through Grammarly.
Trying to go to the live. Okay, so this will be the link. You know, the link will be in the chat. You just have to click that, and basically when you click that, it'll take a little while to download.
but when it does download, you know, it'll be available kind of right here, like any program. So I opened it. I went ahead and opened it. And it basically will get you to, I don't know if you can see it. I want to make sure you can see it. Okay, I'm gonna now show you what I'm seeing. Create new Windows capture. Okay, so I just want to make sure it's visible. Okay, yeah. So let's install Java. Just go through the license agreement. That's where it's going to be. So notice it's installing the Java JDK. So it's going to have things like the Java compiler, the Javac, that's the Java compiler, and NetBeans. So what is NetBeans? NetBeans is just a program to create programs. That's called a, you know, an IDE, a programming environment. It's actually called an integrated development environment, which is basically like, every time you can hear an IDE, it's just a program to create programs. It's how you code. It's a program to code. So like, some people try to overcomplicate the definition, but it's just a program to create programs. And NetBeans actually you can use more than just Java, but for this purpose, it's just going to be Java. So next, I mean, I don't really need to install it, but I'll just do it anyway. I think all it will do is it'll just update the one that I already have. So we'll see what happens. I don't even know. It's been so long. It might tell me what am I doing because I already installed Java, but installation completed successfully. Let's check it out. So I think NetBeans is gonna load. Hold on, I just want to, oh, okay. So now opening up that program. No. Okay, so I'm now going to create another Windows capture. Hold on, I gotta get OBS to get fired up here. Windows capture. Fourth Windows capture I use. Yep. So I think I just want to make sure it's working properly. So we should have Java. So here's what I'm gonna do as a test. You know, I'm gonna kind of do this as a test, but I'm gonna make, without like explaining kind of what I'm doing. What the hell? I don't know what that was about. This feature is not yet enabled. Press next to activate it. Oh, okay. So I didn't install Java yet, apparently, on this system. Download. So yeah, just kind of go through it. I accept the terms of use agreement. Let's just see. Okay. The NetBeans IDE installer has successfully installed the following plugins. Activating Java. Oh. Yeah, in OBS it didn't capture any of that. So I'll have to make another Windows capture. So I'm going to call this program Hello World. This is going to determine that everything is working correctly. Tutorial. Hello World tutorial. You can call it Hello World. Apparently I already have the Hello World program. So, I want to make sure OBS looks normal. It does. Okay. Yeah, that's very strange. It doesn't have a main class. I'm going to just make another program. And call it that. Okay, so this is, I guess, a problem you're gonna run into. So we can fix this. Yeah, so it's supposed to... Well, maybe a new Java class, I guess. Very strange. So yeah, so it's supposed to have a main class. I don't know why it doesn't.
That's a problem I'm kind of facing. There's no option to put in a main class. Yeah, okay. Yeah, so basically, that's how you install it, but I'm actually just gonna leave it kind of limited to just installing it for now. I need to figure out how the new Java program actually works, but what I was trying to show you is I use kind of a more simpler version of NetBeans, which I'm about to show you right now. Is it would have basically something called a run class. So this is what I use. So basically, if you have a Java program, it would be kind of a class built in it. A class built in it that would basically be called a run class, and basically what that would do is that would be the first thing that gets run. So basically what I wrote here was system.out.println hello world, and what that would do is that would translate to an output of hello world, and that would just kind of show that's actually like a very basic programming, which that basically shows that your program is working. You know, like whenever you start a language, it would be you would figure out how to get it to display hello world, and that would be how you would determine how it's working. So next time, what I'm gonna do is learn how to work with the newer version better, and start programming with that version, and starting to create a bunch of programs. But for now, I think that's about it. Yeah, now I'm just gonna kind of see chat, what's going on in chat. I'll just leave all the other ones. Okay, well, yeah. So, so until next time, what I'm going to do is, and also be live, I'm gonna make it so I'm gonna be live and kind of making tutorials that are kind of just chopped up. You know, I'm gonna be basically making live streams, and then within it, I'm actually in OBS. I can start recording the video and then stop recording the video, and you're gonna get to see in real time kind of the development of these tutorials. But I would stress that you really want to start with the kind of go in order from the first tutorial in Unit 0 and then up, and then the next unit in that order, because it just wouldn't make any sense if you just jump into more advanced concepts for anyone, you know, when you just haven't been exposed to previous material. So yeah, so eventually I'm just gonna chop those videos up, you know, re-upload them, premiere them. I want to try to get a good amount going, you know, at a consistent rate. And, you know, we're gonna get right into Java, and, you know, even kind of showing how other languages work, kind of key programming concepts, and yeah, and kind of the rest wouldn't really make any sense, but yeah, for now, that's all. I'm going to actually end the stream. And leave it up for a while, and then probably, I don't know, re-edit it or something. And you'll see kind of parts of the stream which will be the video tutorials uploaded in that order. So that's all.